in getting in. David, I just saw your message. Sorry, I didn't get to it earlier. Okay, what we'll do first is a little bit of an introduction and overview to what we're going to cover today. I'm going to link back to what we covered yesterday and as context for today. For those of you that were online yesterday, the main difference with today is that we will have more discussion about potential ways forward. I think we started to have a lot of that dialogue yesterday. So, all right, so just without, I guess, further ado, we'll get going officially in this context. I'm just going to share my screen. Okay, so welcome everyone to the second meeting on oceanic applications for the Earth Observation for Government network. Before I start, I would like to acknowledge the traditional owners of the land and waters on which we're meeting across Australia, pay our respect to their elders past and present, and recognise their current and emerging generation of leaders. Also acknowledge that they have looked after the land and waters on which we're working for millennia, and also acknowledge that Earth Observation Australia and other groups are working with Indigenous groups to try and integrate the approaches that we're taking for understanding and managing the environment. So a bit of housekeeping. We are recording everything that you see on the screen, on audio. Anything you type in the chats, even if it's private chats, gets recorded today. So just be aware of that. What we will do with the output from today is provide that in a summary report, which will set out some actions going forward. I'm going to do a little bit of a recap about what Earth Observation for Government Network is and where we're going with this in terms of the water area. And then we'll get into today's discussion as well. If I could ask you to just keep your microphones on mute while we're talking. When we do get to discussion sections, you can put your hand up and we'll try and talk in turn, or type something in the chat window and we'll get back to you as well. Right, and before I start, I do want to acknowledge Larissa Marfan and also David Antoine for helping to get this session together. Okay, so, all right, so I want to talk a bit about Earth Observation for Government Network to begin with. I do want to acknowledge Stephen Sagar from Geoscience Australia for this image, which I'm showing here at the moment. But the purpose of having Earth Observation for Government Network is to help us look at the activities that our Commonwealth Government is delivering as operational products and services for government, private industry, defence, education and research to actually use. And some of those activities, we'll call them, they're operational, and operational is different things for different agencies. But in general, it does mean that there's a data stream available on a consistent basis. Those data are calibrated and validated, as are the products and services that come from them as well. If you look across the Australian environment or environments, there's a range of different terrestrial environments there. We have different Commonwealth, state and territory and local agencies that are responsible for those. And in a lot of cases, the data sources are changing, the processing algorithms are changing, people are actively figuring out how to produce new products and services. Some of those activities take place in universities and research institutions, some in state and territory governments, some in Commonwealth agencies, and some in private industry. The aim of EOGN is to try and look across that spectrum and help us try to link up the activities so that the delivery of products and services operationally is ideally based on the best possible science, research, otherwise, to collect data, turn it into validated, usable information. Earth Observation for Government Network was started in 2018. In 2019, we had sort of our initial national meetings. And then this year, we've had targeted workshops looking at vegetation products, particularly vegetation cover and biomass. We've also looked at land cover and land use, and most recently looked at crop mapping and classification down to the individual field level across Australia. And all of those activities have been workshops where we've got people doing research with people doing operational delivery, trying to figure out how to talk together as well. And in a lot of cases, those communities already have mechanisms or fora for integrating research to operations. I mean, if you look at land use mapping and crop classification, we have the Australian Collaborative Land Use Mapping Program, which links state and territory through to Commonwealth government delivery, and now private industry are also involved in that as well. As we saw yesterday, there are activities like the Forum for Operational Oceanography, which do link things together, but they're slightly infrequent. So one of the other activities that was identified as a priority in Earth Observation for Government Network was Australia's coastal and oceanic offshore water resources, in addition to terrestrial above and below the ground. This particular workshop is going to be focused on just the coastal and oceanic areas. There will be subsequent workshops looking at above and below ground water quantities and also water quality as well. So these are really focused just on the ocean. So if you looked at these environments, there's a whole range of agencies in Australia that collect satellite imagery, integrate it with field-based measurements, and deliver it, whether it's to local governments, states and territories, Commonwealth, private industry, defence. If you look at the groups that work around that space, here's one version of it. There's a whole bunch of horrible diagrams like this, but these are people that are collecting and using Earth observation data. So non-government organisations, industry, which is everything from single-person companies through to international companies. We've got universities, we've got research institutes like CSIRO, the Australian Institute of Marine Science, our Antarctic division as well. We've got research infrastructure, and this is a really important one for coasts and oceans, our national collaborative research infrastructure capabilities. And then we've got our government agencies as well as defence. So everyone here collects and processes, uses Earth observation data. And there's some other activities going on above there, which I won't get into. Earth observation for government networks, ideally trying to link up from the sort of research side through to operational in government. It's initiated by Geoscience Australia, but it is trying to engage a broader set of people. There's some other activities in there that I won't go into, but EOGN's really across this area. So just going back to what I said before, middle of 2019, we ran a prioritisation workshop. It identified a number of national priorities where we needed to look across Earth observation. Water was one of them. We started to look at these in detail into 2020. We essentially have run a whole series of online workshops. And what we're moving into now are these water workshop series. This is the first one on oceanic waters, looking at both biological and physical properties. We'll look at water quality early next year, and then water quantity as well. each of these workshops has three components. The first session is about what's happening in general, and that was yesterday, and I'll just recap on that. Today's session is really, what are the things that are being pushed out of research, and what's sort of the pull from government agencies to taking those in. And then the final session on Thursday, it's like, well, how do we actually make those two things work together? And the intent is to capture that information in what we've called reports or transition plans that essentially talk about how do we move this research to potential operations space further. And it's trying not to reinvent the wheel and trying to move things forward that way. So dealing with oceanic environments here, there's the aims, establish what's going on, and then look at how do we collaborate further in this particular space. Yesterday was session 1, today's session 2, and it's those push and pull factors that I talked about. And then Thursday is how do we potentially move forward collectively in this space. So this was the outline yesterday in terms of what we covered. I did this background in a shorter version. David Antoine went through and explained 4 key dimensions of looking at oceanic Earth observation products and presented a number of case study applications. If David's agreeable, we'll put those slides up at a certain point. David, is that going to be all right to do that? Okay, I'm getting a nod from
David. Yeah, you want me to bring them, or you get that, or you will do it, or?
I'll check with you to make sure we get the latest version and put it on.
Okay, I can do. Okay.
But what David presented there was a good overview of both the biological side of things as well as what I'm calling physical. So biological, looking at ocean color, water color, also looking at sea surface and ocean temperature, and then physical, looking at sea surface state in terms of winds and waves. We're also reminded by Helen Beggs and others of looking at sea ice and other properties as well as key components. And then David presented some case studies showing how a lot of the satellite imagery is brought in and then delivered as information. Several Australian examples from the Integrated Marine Observing System, and then also an example from Europe in terms of the Copernicus program's Marine Environmental Monitoring Service as well. So we'll make sure those slides are up there. And there is a survey which we're asking people to fill out. I might just ask Larissa to send the survey link around to everyone as well. Also just comment on Arnold's point, algal blooms. Yeah, I think, Arnold, anything on top of the water surface and in the water column is part of it. So I'm trying to be inclusive, and it's, yeah, I may make some glib statements like, well, aren't algal blooms part of ocean color, but I'll just leave it at that. So yes, Arnold, to answer that question. The survey, I'm just going to get Larissa to post that link so people can see what the survey actually is. The reason for doing the survey is that lets people think about some of the questions of what's out there, what are they focused on, where do they think we should be going in terms of like research push, but also people from a policy side or user side to go, well, this is what we actually want. So today's workshop is going to be a bit more discussion around those things. And then in Thursday's workshop, it's like, how do we potentially move forward? I'm not proposing we set up a national oceanic Earth observation capability, but I would like us to think about how do we move forward collectively in this space? Do we engage and push things like the Forum for Operational Oceanography? How do we do things that are going to help with the transition of products into operational agencies and making sure people are focusing on research which is going to be usable and useful, and also that we can engage with international science and other missions in this space, which a lot of us already do. All right, so just before we get into discussing a few things, I want to just show this diagram again. The diagram, we're going to look at a progression going from right to left, from basic research through to testing it, to making it work and getting it applied. And what we're trying to do with Earth Observation for Government Network is to get a sense of what's at each of the stages here, and then work out how we can start to move things forward. Whether it's in the collaborative research infrastructure space, whether it's targeted research funding or other activities. So, we've already got a number of groups that work across these different levels, and EOGN's about, well, what's going on in each of these areas really in terms of oceanic applications, and how do we push it along, and then how do we push that information up to other groups to say, look, this is where we need to direct effort and funding to. So for today, done a welcome, bit of housekeeping. I've done an overview of how we got to where we were yesterday and where we are today. And I'm going to talk about what to get to in a second as well. So what we want to do today is really two, discussion sessions. And these are around two areas. The first one, which will run from 12:30 to just before 3, and then the second one. So it's really about how are people using these data sets, what are key priorities, and what, if people were asked, do you consider is, a key algorithm, product, or activity which has been developed and tested, and it works over large areas and could be pushed out to being operational. And everybody's likely to have different views on that, and that's fine. And then we did want to finish in the final 10 minutes looking at research to operations. And these actually relate, those 4 dot points there under strategic research infrastructure, calibration and validation, and skills development relate to what's covered in the survey there. Arnold, I'll get to your question in a second. I'm just going to change screens, but David, did you want to add anything else based on discussion or reflections from yesterday in terms of what we've covered?
Well, not much, except maybe I think I remember it was raised that we first need to get to know a bit better what's going on in that space in terms of what is already being transitioned or already transitioned to operations. We not necessarily have a comprehensive view of this. And the other thing was just to avoid duplicating efforts. So, if there are other groups currently discussing this, working on this, of course, we should know and try to be connected with them and avoid duplications. That's basically my take from yesterday.
Thanks. And I think thanks, David. And I think just to build on that, we don't have a huge community working on this, and there will be different discussions, and we actually heard about different discussions yesterday, whether it's in the Met Bureau or in research areas. And part of these sorts of activities is to make us aware of those discussions and start to make links. There's always going to be overlaps, but where we can work together, it's good to find out about that. One of the other reasons for doing this is that as an Earth observation community in Australia, if we're able to work together more effectively across oceans, coasts, terrestrial, atmospheric, and subsurface, I know that's challenging, but we are able to potentially leverage more support for what we do on science to operations, supporting government activities and research. And I think those of you that I've worked with for a while, I know a lot of you share that, but it is a complicated space. I think if we look at when IMOS was established, and then we had Oscope and Turn, there was a lot of cross-fertilisation. Some worked, some didn't, but we got ahead because the different communities worked together. And I think we're at a point where we really need to do this again and really try to push forward a little bit. And I also say that in terms of being able to build the next generation of people coming through as students and early career sort of staff and things like that. I think we can really get a much better set of people here. Okay, so before we go to discussion, I just want to switch out to this screen. What you're looking at now, I know it looks slightly horrible, but when you fill out the survey, which Larissa just posted the link to, your responses go into a spreadsheet where we can see basically the columns are the questions and then the row is your answer. So I'm not going to identify people. You're the next column over. But what it does let us do is, collect everything and synthesize things, and we'll provide this in a report afterwards. So this lets us look at key things like what are people actually working on, what are your policy drivers, those sorts of things, validation processes that are being applied, is there an increased role for calibration and validation services, those sorts of things. I'll come back to those later on. I've highlighted a couple of the key things for the next sort of 30 minutes or so discussion that I wanted to get some feedback on. The first column was, well, what are deficiencies of products? Okay. And that's around, I guess, temporal, spatial, spectral, radiometric resolutions of your actual data sources, and then algorithms. That's important information because it helps us push, where do we want future missions or what do we support down the track. This next one's a pull factor. If you're a science agency or a monitoring management agency, what is it that you actually need that you don't have operationally at the moment that is important, and what's more desirable. So I was wondering if we could spend a couple of minutes just on if people are willing to discuss these three things, because they're partly related, and then we'll go into another three activities there. Keep in mind, there's only another 30 minutes or so left, so we try and keep these discussions quite focused. So the way that we would typically do this is you can type a response into the chat window to provide more context to what's in the survey, or if you do want to talk to some points, please put your hand up and we'll basically go through and talk through things there. And just while you're thinking of a response there, I just want to go to Arnold's point there, which is more than a question, saying that it's relevant to realise that inland waters flow into estuaries, that flow into oceans. How do we manage that in an operational sense, as in plumes going out into the offshore area? That's a really good point, Arnold, and it's very hard to draw a definite boundary in this space, which is why we've called this coastal and oceanic waters. So yes, it does extend into estuaries, and you'll see that when we do water quality, that it's also going to be inland as well as coastal areas as well. So I think we need to start having sort of diffuse boundaries. But maybe this is a good starting point for a discussion around the coastal context. Is this really a problem? Do we need a solution? It's an area that falls sometimes between the gaps in jurisdictions as well. Any other thoughts on coastal ocean boundaries? If not, I'm really happy to talk about, are there critical deficiencies in current ocean monitoring product?
Stuart, that's the problem, because those deficiencies, by using the standard ocean color products from NASA, which is currently in practice almost, except in the Great Barrier Reef, we do have the problem that in the west coast of Tasmania, you've got very CDOM-rich waters flowing into the ocean, and they're misinterpreted as chlorophyll, because essentially the NASA algorithms are a blue-green algorithm. So they confuse CDOM for chlorophyll. When we do have tropical river plumes flowing into the ocean, the standard algorithms can't deal with that either. And Gulf of Carpentaria is a very unique ecosystem that often shows up when the space agencies show error maps. It also always shows up as a massive error area where everything is quite wrong. Now, 80% or 90% of the standard ocean color algorithms work fine for Australia. As long as the waters are blue or blue-green, you're okay. The moment they change from blue-green, basically we haven't got a clue what the standard algorithms are providing. And I think, if we want to be trustworthy, we should either flag and say, look, these areas are uncertain and need more research, or we should start implementing better algorithms. Now, we had better algorithms, but that kind of died a slow death because of people like Vittorio Brando and others leaving, and the team at SARO splintering or fragmenting. Of course, we have got a new ocean color expert group with David Antoine in Curtin, so that's great. But we've actually gone backwards in algorithms and reliability and validation. Especially in those extreme cases. The Lucinda Jetty and the Rottnest Island calibration validation stations are fantastic for vicarious calibration and for those type of waters, but I do believe we need to think about what is needed in Australia to make all those coastal and ocean observations reliable. And I don't think we're there sufficiently.
Thanks, Arnold. There was multiple points in that, one of which is algorithms suited to local conditions, so that we've got products and services that are suited to them. The second one, which I'm going to keep coming back to, is skills and capability shortages in this area as well. So thanks. I think that pointed out a key point. What we might do today, given that we've actually got a number of people online as well. So David, sorry, we'll go around everyone unless there's hands up. I'll go to David first.
So,
yeah.
Can I start? Yep. Okay. Just to answer to Arnold and generally, well, I was not totally sure whether initially when we started to plan this workshop that the coastal environment was already included, or we were just basically thinking to the open ocean, but that's fine. My view on this is still connected to the need for more field work. Because if we want, you mentioned the Gulf of Carpentaria. If we want to do better there, we need to go there. We need to, look at the optical properties and see what happens, and end up with maybe the specific algorithms for that area. Same thing for the GBR. That's always the same thing, and significant part of the efforts, not necessarily in Australia, but generally in terms of developing new algorithms have sometimes just concentrated on, using all sorts of different techniques, neural networks, genetic algorithms, whatever, but not necessarily having, done much on really understanding better what's happening in the water. So going there, collecting IOPs, AOPs, and ending up with, at the end, something better. So that's one thing we still need to do. I can just mention that as part of IMOS, we have started a process to try to make an inventory of radiometry measurements around Australia, and with maybe the final goal to homogenize a bit the processing and make this data set a bit more consistent overall and available for the community, so we could use this to start doing this, developing more Australia-specific coastal algorithms for coastal water. So that's one thing we can do to improve this. And definitely, if we want, government agencies, state departments, whether to use a bit more this ocean color stuff in coastal waters, we need to do this, because that's the way to improve the relevance of the product and the quality of the product. So that's, again, quite significantly connected to the in situ work and the field activities we need to have in parallel to the remote sensing processing, I guess.
Thanks, David. I guess I'm keen to hear from, so we've heard a fair bit just about ocean color there, from the point of view of sea surface altimetry, I guess looking at ocean surface winds and waves. Is that localized validation and refinement of algorithms something that's required for those sorts of products as well? I'm not sure who the best person is across that space, given that we've got a couple of people there.
Yeah, I can say a bit. So there's quite a lot of activity stood for wave validation. It's primarily in situ buoy measurements, and there's a growing number of coastal buoys around Australia, regionally speaking, but the open ocean waters in this region are they have very, very sparse buoy measurements. So this is globally this has been a challenge in especially in wave measurements in the Southern Ocean or the Southern Hemisphere, as well as the tropics. But there's a growing network of coastal buoys around Australia, and new technology is being tested as well in terms of low-cost buoys for validation of wave data. I guess some of these of the bigger traditional systems sometimes also carry wind anemometers, so they can measure wind speed and direction. So that's where the CalVal for that particular variable is also facilitated. Yeah, so there's quite a lot of stuff happening in, I think, under IMOS as well. I guess a lot of us are familiar with that in this meeting as well. Yeah, was there anything else in particular that you?
I think it looks like Shane's added some comments in there about the satellite altimetry side, but it's also the IMOS, I guess, UTAS capability for that in Bass Strait as well. I guess the one that we haven't covered, and I'm not sure Helen or Edward, is if the sea surface temperature validation is that something that there's an adequate network of sites for actually?
Yeah, sorry, I concentrated on the sea ice products in my response to the survey.
Mm-hmm.
It was taking up rather too much of my time.
Okay.
Responding to the survey, and I kept losing what I had typed in because it
Yeah.
doesn't save, which is annoying. With the validation of satellite SST, currently the ISAR on the RV Investigator is one of the very few instruments of its type in the Southern Hemisphere. And that data is heavily used by JAXA and EUMETSAT for satellite SST validation. I'd like to use it too, since it's sort of my project, but we haven't got around to it at the Bureau due to lack of time, but we are intending to use it for validation of satellite SST, especially of the geostationary satellite data, such as Himari 8. Yeah, it's been published in 2 papers. The data was used to validate other products, and it's currently used for validation of Sentinel-3 SLSTR SST. So it's a very important data set. And now I thought I might have put in my response, I can't remember, I should have, that the new Antarctic vessel, Hayuna, it's going to have an ISAR, but they are vastly underfunded, under-resourced for manpower to actually operate it correctly. So if they don't maintain it properly, it will be useless. So that would be a great shame. So that's a gap. Maybe I didn't put that in my...
Yeah, that was partly...
I should have if I didn't, because yeah, that shouldn't be missed out, because unfortunately the AAD, it's unclear if they'll have anywhere near enough engineering staff to maintain the instruments that they've purchased and calibrate them, which is very important if they're going to be used for satellite CalVal.
I think, thanks, Helen. I mean, this is partly the reason for having that discussion, as and apologies, the survey form's a bit clunky.
Yeah. If I'd been able to save each page, I wouldn't have had to retype it. So.
We will take that on board in terms of what we do in future. It's a balancing act between whether we use SurveyMonkey or this or something else. But that's really helpful, and that's partly why we're doing this.
Yeah.
I guess that point about suitably skilled people and resources to set up and maintain calibration and validation does sound like it. I know from a terrestrial point of view it's still a challenge, and it does sound like it's common across each of the different component areas here as well. So
yeah, well, CSIRO has an engineer who's made it her business to become an expert, the Australian sort of expert on the ISAR, and she knows far more about it than me because she does the hardware and the calibration and everything. But it really has been a complicated beast to maintain.
Yeah,
she's done an amazing job, but it's not trivial. And yet, when it's done properly, it is the only way to properly validate satellite SST. And this is well known. And there are several instruments that produce skin SST on vessels around the world, but they're sort of in the Northern Hemisphere. And the only other one that does any transects is the fairly recent, in the last couple of years, the British Antarctic Survey research and resupply vessel, I forget its name, that goes from South Africa. That one, that does a few transects, but the RV Investigator and in future the Nunya will provide regular transects in the Southern Ocean, and the Southern Ocean is not like anywhere else on the world, as on Earth, as we've discovered for skin SST. So it is valuable to get good data from there.
Okay, no, that's really helpful. Thanks, Helen. We might just keep going around. Steve Sager, I'm sort of aware you're one of the few agency people here. Thanks for joining us. Did you want to provide a perspective from a GA point of view in terms of, I guess, oceanographic products that are of interest and where you might see, I guess, the agency going in future with them?
Yeah, so I guess I have to draw some parallels back to what we're sort of the wheelhouse we're in at the moment in terms of Landsat and Sentinel-2, but there's overlapping issues, and also there is a discussion around, you know, where a Commonwealth agency sits in terms like GA in terms of embracing oceanic products. I mean, we've got the Copernicus programs, we've got access to these Sentinel-3 archives and things like that. So some of these issues, they come back to what's been brought up in terms of the validation as well too. So there's these two sort of schools of thought within GA, especially, is how much do we invest in generating products that are bespoke and for a local environment and trying to adapt to local conditions, as opposed to how much energy do we put into trying to influence other agencies to better produce their products for different collection runs and things like that. And having that lack of validation data, so if I go back to sort of the stuff that we're doing with Aquatic ARD, which is for Sentinel-2 and Landsat, but also parallels any kind of local implementations for Sentinel-3, is to make that argument. I mean, we've found a lack of validation data across the different water types, both coastal and through inland water, to actually be able to quantify that improvement that we're going to sort of say we're going to get out of doing our own, cook your own approach, as opposed to taking the core, ESA data. So I think that flows then on to the different algorithm tests, and let alone the ARD and level 2. So I think that validation data set is it's really important to sort of firm that up. We've tried a lot with inland water, and we're trying to see if we can sort of translate that to coastal waters, but it's a challenge. And I guess one of the things that a different engagement point for us is trying to get buy-in from Commonwealth agencies that need this data. So trying to get that policy buy-in from people is, we found it very hard for them. The thing that keeps them coming up for people like Department of Environment is ease of use and access to the data. Even if we sort of build portals for ourselves that we think make it quite easy and we're getting better at it, etc., we're always a little bit surprised at the bar, that how low that bar has to be before people will actually bring that data in and make some decisions, or make some statistics or comments on that, to the point where essentially they don't care about the Earth observation data most of the time. They just want the statistics they can get out of it. So that combination of lowering the bar of access of data and interpreted products, and also then giving them tools to get that information out of there, is probably one of the biggest barriers that we saw for things like state of the environment reporting and things at that level. Is if they had a mechanism, rather than having to sort of pay us to be as part of a project to help them out, or an institute, having that bar lowered would be something that would encourage, and perhaps they don't use it a lot of the time. If you look at the state of environment status drafts that came out a couple of months ago, is in some of those indicators for all water types, there was barely any mention of Earth observation or products in some of those, and that's a bit of a worry. We touched base with some of the writers of the state of environment stuff, and they're like, oh yeah, we'd be keen, we just didn't know about any of these data sets. And if that information never gets out of the department, or GA is probably doing a bad job communicating it, but I think it's that ease of access which stops that uptake sometimes.
Thanks, Steve. I think the point you made about where you've got groups that they just want the relevant numbers to their activity, we're seeing in a number of other sectors as well, and there's still the communication engagement exercise of working across what we do and those groups as well, and that's partly why we're having these discussions too. So sorry, Edward, you had your hand up.
So could I add something there, please, Stuart? So I think there's two problems in what Steve mentioned. There's the perennial bugbear about knowing about data and being able to access it, but then there's also the ability or the capability to make use of what is actually a sophisticated measurement. We've heard that they just like the statistics and move on, but for products which are revised over time as methods improve, that causes discomfort because the historical data then changes, so the statistics are different from what they were last year, and so there's a significant barrier, I think, to getting proper uptake of some of these products, which is simply because although they're conceptually simple, they do require a certain amount of sophistication and engagement for people to use. And that's a whole new layer of challenge for us.
Yeah, I mean, I guess, so I'll be a bit of devil's advocate. I mean, isn't it just a matter of an FAQ or here's the product disclosure statement that comes with it? And I'm not saying that's the answer, but isn't it just what, yeah, I mean, is it more than just, well, here's what this is, and please be aware that in a year's time, we may reprocess the whole archive and there'll be an improved data set which may have a different answer to before. Yeah.
Yeah, so I mean, if we were upfront about those sorts of things,
Yes.
and people are accepting of them, then I think that's okay. But it's not always the case.
No.
In fact, so we've had quite a lot of experience where it's not been the case.
Yeah, I think even if you communicate that up front and you do reprocess it and it changes, so we see this, I think you've seen it with some water quality activities. We've seen it for our statewide vegetation mapping, where under one approach, this much of the state was cleared. And then in the next year, well, that year it was only this much. And when people are being fined and money are being paid, it's not just a matter of, oh, our processing approach has changed. Now you got a different answer. So I don't know how to solve that one. I think this is one of the things these discussions are really helpful in pointing out, because as a community, we do need to let people know about these things, and also particularly about error and accuracy checking and what that actually means as well. Too cool. Right. Thanks, Edward. Just going around the table still.
If I could just quickly add something on this. Yeah, sorry. I think another thing that we probably need to improve if we want to have a better use by government agency, whatever, is we need to have ourselves the capability to process and generate specific products, and not only being dependent on what ESA or NASA or whoever is doing. So I think that's because otherwise, you just have to wait for them to improve the product or to redo something, and you're really highly dependent on that, and it's difficult then to serve the needs, the local needs very properly. So we need to develop our capacity to be independent in terms of generating products, validating them, and delivering them to our users.
Thanks, David. So you're talking about, so that's using foreign data sources and then products here, but also potentially Australian data sources.
Well, at some point that will probably, hopefully, be some Australian remote sensing data source, but for the moment, yes, it's mostly using the raw data from this space agencies and missions, and generating what we really need with the specific algorithms we want to use, and not being too much always depending on what they do and what the product they offer.
All right. No, I think that's a really good point to include there. Thanks, David. All right, we're still trying to keep going around and keeping an idea on time. Pallavi, was there anything you wanted to add in here that we might have missed?
No, I think Helen have added.
No worries. If people do think of things along the way, let us know. Shane, you typed in the point about the validation. Was there anything else you wanted to add in?
There is potential for involvement in calibration activities around sea ice. I think this is something Helen was talking about, connected with the SWAT mission. that would be somewhat more speculative, I think, in the sense that it wouldn't be operational, but it would be a secondary data product from the SWAP mission. The question there is, how do you resource it?
Yeah. Actually, we'll come back to that just towards the end, because I think we've got some options there for doing that. I think Helen had a clarification question there too.
Oh yeah, just that I put this in the survey, but I'd just like to highlight to people that what the Bureau is currently discussing with the Space Agency, Australian Space Agency, and what we're really concerned about because of what we're doing at the moment is the complete lack of verification of satellite sea ice data, any type of satellite sea ice data over the Antarctic. There's just hardly nothing. It's all the verification with buoys, in situ data has been done over the Arctic. And we know that the Antarctic is very different to the Arctic. The sea ice behaves completely differently. And this is going to be quite an issue for us as we go forward into the future, trying to predict sea ice and the weather over the Antarctic. So, yep. So that's what we are currently most concerned about when it comes to verification of ocean satellite data. That's all. I just wanted to stress that.
So just can I dig a bit more on that? How do you validate sea ice mapping? Oh, sorry if that's an ignorant question. But
with difficulty, I guess. I'm not an expert in this. I've only just joined the field in the last 12 months, but you can do it from ships. There is going to be, with a new vessel, I was in a workshop a few weeks ago with the the Marginal Ice Zone Alliance, people from all around Australia talking about what we'd like to do with a new vessel. And they have ideas. Petra Heil is really an expert in this. Is she at the AAD or the CRC? I forget. Anyway, in Hobart. And so there are people at the AAD and the Antarctic CRC, or whatever it's called in Hobart now, who are far more across this than me. I just know that we are concerned about it at the Bureau, and ice thickness needs to be verified, albedo of the sea ice concentration, of course, but there's a lot of work to be done. And this has been going on for years in the Arctic. There's so many more people who are studying the Arctic. There's so few in the Antarctic, and yet for Australia, it's important to us. So for government and, anyway.
I think it'd be fair to say it's just become quite important.
It's very recent. It's only been the last year. Suddenly it's the flavour of the month. I'm going, where did that come from? But it's political.
Stuart,
sorry, go ahead, Simon.
I just wanted to maybe point out, if that is interesting, there's a couple of other applications that are that are quite interesting. One of them is led by Chris Wilcox at CSIRO, who works in illegal, unregulated, and unreported fishing. And the primary application there is surveillance using high resolution coverage by primarily synthetic aperture radar, or also other satellites that have high resolution to actually to detect illegal fishing boats, etc. So that is one area that might not be exactly under the current theme of this meeting, biological and physical variables, or but it is related in a way, I guess. And I guess another aspect is also tropical cyclones and intense systems, and studying their wind structures, etc., using scatterometer and also synthetic aperture radar winds. So those are, I think, a couple of applications that I thought that were not maybe I didn't talk about earlier.
Thanks. Yeah, I've made a note of those as well. I do think, the surveillance aspect, you are looking for features in the oceanic environment, so that's part of it. Obviously, like Novasar and some of those other activities are partly involved in that. But I think we shouldn't forget that, I mean, in terrestrial environments, monitoring infrastructure, whether it's, power or water, is a key Earth observation monitoring activity. So ideally there would be similar things for infrastructure operating in oceans as well. So that's a good point. So.
And just to add, just another one that comes to mind is oil spill detection. And that has lately, I mean, the last year or two, there was at least one project going on that. And one of the applications of Novasar as well.
Yeah. So thanks, that was a good point. All right, I'm just conscious of time. Aruj, I think I hope I got your name right. Did you have any other points to add to the discussion?
Thank you very much, Stuart. No, actually, I'm from catchment modeling background. I'm a hydrologist from Bureau of Meteorology.
Okay.
So I work mostly like catchment modeling work. Currently we are dealing in the we are working for the Great Barrier Reef, so E-Reef project. So we are setting up distributed hydrological model there, and we use Earth observations such as digital elevation model data and drive the flow direction and flow, these kind of information. So I'm from slightly different background, just kind of a listener and like learning these things. But yeah, no, I agree. A very good point were made. I would simply say one thing. I think if more ground truthing or like more validation would be considered, that would be great with these observations. Otherwise, I'm good. Thank you.
Thanks, Aruj. I've made a note of that as well. Also noting the discussion from, so just going to deal with sort of Shane and also Edward's response there. This is actually a really large area of work where, you've got most vessels above a certain size have an automatic beacon on them. And so usually the detection is matching up the beacon location with an object you see in the image. And if they're don't match up, then there's something going on. CSIRO's Novasar project, which is where CSIRO has a share in Novasar. That particular satellite has a transponder that picks up those ship beacons as well as collecting synthetic aperture radar data to match up the two. So lots going on in that area, but it's same environment monitoring. Just back to Arnold's question about PACE, MODIS and VIIRS and enhanced hyperspectral capacity. I think that's a good point. The discussion today is actually getting to a good point in terms of, we're continuing to use these products. There's continuing challenges and limitations with having them validated and working properly for Australian conditions. And I think that's something that we'll pull out of this in terms of going forward in the discussion on Thursday as well. So just to finish off with in the last couple of minutes, given that we are at time, one of the last 4 dot points I was going to cover was on, I guess, strategic science, and then we had research infrastructure, calibration, validation, and skills development. The reason we finish with them is they're the transition into the discussion in our final session on Thursday. So I might just highlight those just again as a way of finishing off today, because those 4 points actually highlight a lot of the gaps that we identified. So the 4 which are down here, in the, not so much the science to commercial, but research infrastructure, calibration, validation, and having appropriate people in place. We'll come back to these on Thursday in terms of driving the discussions on. There will be some key, I think, observations that come out of this small set of workshops, and we can present them as key findings and suggested ways forward. And so this will come out as the, I guess, workshop recommendations. We will try to use them with the Space Agency's Earth Observation Roadmap. Hopefully we can use it to influence other activities, whether it's our own organisations, NCRIS, the Australian Academy of Sciences and Technical Sciences is doing a space science decadal plan at the moment. You know, it's looking for, you know, where are their skills gaps. There's going to be serious reconsideration about research infrastructure in relation to space-based activities, and this fits into it. So just acknowledging that we're on time today. Thank you, everybody, for your attention today and contribution. And we'll return on Thursday to pull things together to a final set of recommendations and keep things going. So again, thanks everybody for your input. That was really helpful discussion, and we'll catch up again on Thursday. So thanks everyone.
Thank you, Stuart.
Thanks, Stuart.
Thank you.
Thanks very much, Stuart.
Bye.
Thank you.
Thanks, everyone.